Hi guys, how you doing? Today we're gonna be treating the triplet sum, which is another one of the most commonly asked data structure and algorithm problems by top tech companies, including Google and Netflix and Microsoft and Amazon and Meta and other top tech companies. So if you're gonna be doing your tech interview, there is a high probability that this is one of the questions that they are going to ask you in the second stage, most likely in the second stage of your interview, so which is the online assessment stage. So we are going to be solving it together. We're going to do it the logical way. All right, let's go to it. The question statement says, the problem says, given an array of integers, return all triplets ABC such that A plus B plus C equals 0. The solution must not contain duplicate triplets, e.g. 1, 2, 3 and 2, 3, 1, and considered duplicate triplet. What they're trying to tell us over there is that we don't want the solution to contain duplicate triplets and 1, 2, 3, 2, 3, 1, 1, 3, 2, or any combination like that are duplicates, provided they contain the same sets of numbers. So you understand, if no triplets are found, we are asked to return an empty array. So what's the interpretation of this problem now? We are given an array of integers and we are asked to return all the possible triplets such that the sum of these triplets will equal 0. You understand? And as we can see in the example given, there are two sets of triplets that sum up to 0 in the array. We are given an example input here, which is 0, minus 1, 2, minus 3, 1, and the output is this set of minus 3, 1, 2 that equals 0, because minus 3 plus 1 gives us minus 2, minus 2 plus 2 gives us 0, and another one is this minus 1, 0, 1, which sum up also to 0. So the problem really wants us to return all possible tuplets that will equal 0, or whose sum will equal 0. Right. The most intuitive way to solve this problem is to check every possible triplet in the array to see if they sum up to 0. And if we ever see anyone that sum up to 0, we add them to a list. So we look at every possible triplet. Is it 0 minus 1 2? Is it 0 2 minus 3? Is it 0 minus 3 1? Is it minus 1 2 minus 3? Is it minus 1 minus 3 1? Any possible triplet at all that sums up to 0, add it into the list. That's the most intuitive logic that we can apply. When I mean intuitive, I mean the most reasonable. I mean just something that will occur to your mind. Okay, you're asked to find triplets that sum up to 0. Then let's check through every possible triplet, and if they sum up to 0, add it. If they not sum up to 0, leave it. So that's just the basic logic in solving this problem. Just like the problem statement specifies, the output must not contain duplicate triplets. An example of duplicate triplets is this tree here. We see that the first triplet right here contains 1 2 3, while the second triplet contains 1 3 2, which is the same as 1 2 3, just that the order are different, but they still contain the same set of numbers, which is 1 2 and 3. So we don't want this, but in the process of finding every possible combination, we might have something like this at first, and then later have something like this, and later have something like so. To avoid this now, whereby we will be adding duplicate triplets into our outputs list, so what we're going to be doing is we are going to be sorting each possible combination or each possible triplet that we have. Look at this now. You see that this can effectively solve the issue of duplicate triplets. Why? Because when we have 1 2 3 and we sort them in ascending order, we are going to be having this final result here, 1 2 3, and even if we have 1 3 2, it's still going to be sorted to 1 2 3, and 3 1 2 is still going to be sorted to 1 2 3. So what we're going to do is that we're going to be adding them into a set. first of all sorting them and adding it into a set. And we know quite well that set does not contain duplicate items. So provided we sort them, then add them into a set, it will always remain unique. Why? Because set remains unique. Well, I'm gonna tell you how to go about it. Right. Whoa, motion color 1057. 1057. Hope you understand. All right. Now that we have them sorted, we are going to add them into a set. So looking at this now, let's say our first combination is 1 2 3. We sort it to 1 2 3 and then add it into a set. Our second or let me say another possible triplet that we encounter is 1 3 2. We sort it, it becomes 1 2 3, and when we add it into the set, it becomes 1 2 3. You understand? But sets won't contain duplicate item, so it will just remain 1 2 3. If we encounter another duplicate triplet like 3 2 1 now, it's gonna sort it to 1 2 3 and it's gonna add it to the set, and it's still going to remain 1 2 3 because set is not gonna take any duplicate triplets or any duplicate elements. So this is a way, that's an efficient way to avoid duplicate triplets in our array. Alright, let's look into the code implementation for this logic that we just described. So this is the code implementation. We have our function triplet sum. So, and I actually have the habit of writing down the parameters and the real data before I start writing the code. So, and you see we have our nums giving us -0, -1, 2, -3 and 1, and that's the data we need. So that's what we collected right in our function definition. That's what we have right here. So, and here in the second line we collected the length of our nums, or length of our array nums. We collected this as n, and we are going to be using the add set to ensure that we do not add duplicate triplets, just like we explained in the logic that we explained in the logic that for any possible triplet that we find, we will go and sort them. After sorting them, we will add them to a set. So this way it will ensure that there is no duplicate triplets. So this is the set now that we will be adding them to. This is the set. And now we say that for I in range of n. So here we are trying to iterate through the indices of all the triplets. Why we are using 3 for loops here, 3 for loops, why we are using it here is because the first one is going to iterate through the index of the first element or first number in the triplets. The second one is going to iterate through the for the second element of the triplet, and the third one is going to iterate through the array for the third element of the triplet. So don't forget, we are looking at every possible combination, so we are iterating through the array 3 times. You understand? Each of them representing each element of the triplets. That's simply why we are doing that. So, and now for each of them like that, we are going to check if nums of I, which represents the first element of the triplet that we are looking for, and nums of j that represent the second element of the triplet we are looking for, and nums of k representing the third element of the triplet we are looking for. We are going to check if they sum up to 0. So we are going to sum it up. So if it's going to give us 0, so if it equals 0, what we do is that we sort it, just like we explained in the logic, where we are going to sort it. Why we are sorting it is because we are looking through the different combination. So there's a probability that we will visit the same set of elements 1 2 3 more than once. We can visit one, before 2, before 3, and then again you can visit 3 before 1, before 2. So we need to really sort them so that when they are sorted in ascending order, any combination like that of such will return 1, 2, 3 in their ascending order. So, and after we have sorted it in ascending order, we are going to convert it to a tuple. Why we are converting it to a tuple is because set in Python, set does not store hashables. So it does not store mutables. Mutables and hashables are things that could change. You understand? But because set is unique in nature, it can only store something like numbers, strings, tuples, and other hashables like that cannot change. Hope you understand. So that's why we have to convert the list, the sorted list here. We have to convert it to a tuple so that we can save it into our set. So, but in a situation whereby they did not sum up to 0, it doesn't do anything. It just move on to the next possible combination of triplets. And at the end of the day, we are going to return our triplets, which is the set that will contain the unique triplets that sum up to 0. I hope you really understand this. So, but you know, actually, if you don't understand that I explained now, just go back to the logic that I explained. Actually, this is just a written code implementation of the logic. So once you can understand the logic that says that, okay, find every possible combination, because the question asks us to return all possible triplets that evaluates to 0 or sum to 0, and because of that we want to do the intuitive way of finding every possible triplet and now filtering the ones that sum up to 0. We filter them out. That's the one we need, because that's the what the problem statement suggests, that we return every possible triplet that sums up to 0, or whose element sums up to 0. So when we could gather every possible triplet, we filter out the one that sum up to 0 and we sort them. Why we are sorting them is because we don't want to have duplicates, and then we add them to the set, because set is unique. It can only every element of the set is always unique. So I will return that set now, and you see when we run the code, it gives us the exact if you can check the problem statement, you will see that this is the output, and here now we have the output to be -101 and -312. Don't forget the question says it can come out in any order, meaning that we can have -312 before -101. We can have it in any order at all. So, but it must not just contain duplicates. But this solution is quite inefficient. This algorithm runs at a time complexity of n raised to power 3, which is actually inefficient. Don't forget, like I used to say, you know, these companies, software companies, are not interested in you getting a final answer. That's not what they are interested in. They really want to know how efficient you can solve problems. So they are expecting a more efficient solution. So how can we make it more efficient is what I'm going to explain to you. You understand? So I'm not just solving problems, I'm trying to solve it in the best logical way that we could ever have it. All right, let's assume our triplets ABC, as we can see in the screen. Let's assume it sums up to 0, so such that it is one of the triplets we are finding that the problem statement asks us to find. We can conclude therefore that A plus B plus C is equals to 0. So, and this means that B plus C is equals to minus A. So looking at this now, it means that if we can find one out of the triplets that we are looking for, let's say we found A, then from A we can get B and C by finding two pair B, C, that when we sum it up will give us minus A. So that's just a simple analysis, and that's the logic we'll be using to come up with a more efficient solution than the multiple for loop, which is the 3 for loop three nested for loop that we had the other time. So right now we are going to be iterating through each of the element of the array here, which include -2, -1, -1, 1, 2, 2. Don't forget it has been sorted. So iterating through it now, we are going to be taking it one after the other, and we are going to be taking them as our, this -2 now, we are going to be taking it as our A. So we just want to look at two pair B, C, such that when we sum up this pair, will give us -A, which in this case is minus 2, which is 2. So we are going to be treating it that way. First of all, we pick -2 as A, and we look at the remainder of the list here. If we can find any pair B and C, that when we sum it up will give us 2. Hope you understand. So if you can find a pair B and a pair C, or let me say a number B and a number C, that when we sum it up will give us -A, which in this case is -2, because A is -2, which in that case means 2. So if you can find a pair B and C, such that when we sum it up will give us 2, then we know that the triplet ABC will sum up to 0, and we will add it into our list. So that's the simple logic we'll be using here. Alright, now we picked the first index, the first element of the array, so -2, and we set it as our A. So right now we now know 2 out of the values we are looking for. So we now know 1 out of the value we are looking for, which is A. So now to get B and C, we need a particular B, a pair B and C, such that B plus C will give us -A. Now, given that our -A is equals to -2, given that our A equals to -2, so we need a pair B, C, whose sum will give us -2, which is actually equals to 2. You understand? So what we now do now is that we want to look into our array, into the rest of the array from here to this point, from this point that I indicate with this line to the end point. Now if we can get any pair B and C, that when we sum them up will give us -2, which is 2, because of the A is -2, so we need a sum that give us -A. So alright, now if you look at it very well, you see that it's similar to what we discussed the last time, which is the pair sum sorted. Number one is that this is sorted, we sorted it already, you understand? So you see it's -2, -1, -1, 1, 2, 2, so it is sorted. And another thing is that now we have a target 2 right here, and we are finding a pair out of this whole this list here. We are finding a pair that when we sum them up will give us this target 2. So right now we are going to be doing that. If you really want to have a good understanding of this, go and check my YouTube video. So on the very last video we did, it is pair sum sorted, but we are going to be explaining it right here right now as well. So right now we want to look at the remainder of the list, this one here, and find a pair in this list that will sum up to the target 2. Don't forget 2 is -A, A is -2, and -A gives us 2. So right now we are going to be using this method where we'll be having our left and right at the two extremes. Alright, so we're going to be using the pair sum method just like in our previous video, where we'll be placing 2 pointers left and right at the two extremes of the array, so we can have a full coverage of the array. So right now we have our pointers here, and our sum will be 1, since -1 plus 2 gives us 1. You know, the pointers here, -1 at the left pointer and 2 at the right pointer will sum to 1, and 1 is less than the target we are after. Don't forget the target we are after is 2. So what we do therefore is that we shift our left by 1 to the right. Alright, now we have our pointer shifted by 1 to the right, and is now at the second index. So right here now, it's still pointing to -1 to the value -1. So and we calculate the sum. The sum is still 1, since -1 plus 2 gives us 1. So sum is 1. 1 is less than 2. So what we do again is we shift our left by 1 to the right. Why? Because the sum, which is 1, is still less than the target we are looking for. Right now we have our left shifted by 1 toward the right, and we see that it is now that pointer, the left pointer is not at index 0, 1, 2. It's now at index 2, and the value at index 2 is 1 right here. So we will sum it with the value at the right. You see that it is 2 plus 1. So that gives us 3. Now 3 is greater than the target we're really looking for right here. You understand? So, and therefore we're going to reduce our right by 1. Right is going towards the left by 1. Right now, right have shifted to the left by 1. Right is at the last index here before. So it has shifted by 1 to this index now. And left is still in this index. So that gives us 3. It sums to 1 plus 2, that's 3. 3 is still greater than the target 2. So what we do is that we shift our right index again by 1 to the left, and at this point it's shifted to the left. They are now pointing at the same index, and definitely at that point we can find a pair because they are both pointing at the same index, and just a index cannot make a pair. We need 2 indexes to make a pair. So as a result of that, definitely there is no triplet or there is no pair in the array that will give us -a, that will give us 2 in this case, because -a is -2. So meaning that there's no pair that when we sum them up will give us 2. So therefore what we do is that we move to the next element in the array. So right now we've traversed the array for the first element, -2. Try to check if we're gonna find the pair B, C, that when we sum it up will give us -a, and we couldn't find it for the first index for this particular element -2. So we are shifting our focus on the second element -1 now, and we are going to be checking through all the rest of the array if we are going to be finding a pair B and C, such that when we sum up this pair they will give us -1. Don't forget that it is -a. B plus C will equal -a, and A in this case is -1, so -a will be -1, which is 1. So we are going to be looking for this pair that will give us 1. Alright, now we are calling our method, or you can call it function as well. We are calling our method the function pair sum on the remainder of our norms. Don't forget that our current index is -1 now, and we just want to check for the pair that will give us we want to check for pair within this array -1, 1, 2, 2 that will give us and sum up to this particular value -1. So we want to check for it, and that's what we have here in our norms, and our target is 1. Don't forget that we are checking for this a pair that will sum up to -a. So in this case we give us 1. So really we are using the same thing. We place our left to the left and our right to the extreme right. So looking at the sum here, -1, left is pointing to -1, right is pointing to 2, and that sum up to 1. And because 1 is equals to 1, don't forget our target is 1, therefore we found a pair. Fine. Now that we have a pair that sum up to the targets, let's put this pair down into writing. So we say that the pair -1 plus 2 gives us 1. And we can therefore say that -1 plus 2 minus 1 is equals to 0. Therefore you can say that -1, 2 and -1, this is 2, sorry, is the triplet that we are looking for. Do you understand? So -1 plus 2 gives us 1. we are looking for a target 1. Now -1 plus 2 minus 1 will give us 0, and the question asks us to find the triplets contained within the array such that whenever we sum these triplets will give us 0. Now that we have found the value triplet -1, 2, -1 that equals to 0, definitely we found a triplet. But don't forget that the question asks us to return every possible triplet. So unlike the previous pair sum problem that we solved the last time, where we just found one and we return it, no, we are not going to be returning now. We want to find every possible pair that we can ever find in the array. So, and we found just one. So what we're going to do is that we're going to check on if we're going to find any more pairs. If we're going to look through the array, we can find any other pair in the array, because the question asks us to find every possible pair, not just one, and we've seen one, so we continue to look if we can find another one. So, and what we do is that we shift our left array to the right by 1, and at this point we have our left array situated at an element 1 or a value 1. So, and right here the sum is 3. So 3 is greater than 1 actually, and what we do is that we shift our reduce our right index by 1, so we can approach at a lesser value because it is sorted. So by shifting our right to the left by 1, we reach a sum of 3. 3 is greater than 1, so what we do again is that we shift it the right toward the left by 1 again. At this point we have our left index to be equal to our right index. We can't find a pair any longer, so what do we do? We break out of the loop. Alright, so since we break out of the previous loop here, we move our major index again, which is a. This a, we move it to the right from this -1 that it is previously. We move it to this new -1 here. So, and then we need to check through the rest of the array 1, 2, 2 to try to check if we are gonna find a pair that will sum up to -a, which in this case 1, because a is -1. So, and that's what we do right here now. That's what we did right here. So I already have the array placed there 1, 2, 2, and we have a target 1. So it's just about doing the same thing over again. So after finding all possible pair, we shift the this a right here, we shift it again to this new -1, and that's how we keep to this new one, and that's how we keep extending it. So when we shift it to this new one, what we're gonna do is to check the rest of the array here if we could find a pair that will evaluate -a, which in this case will be -1. After doing that, we shift again to our a to this new index 2, and we will check the rest of the array if we can find any pair that will give us -a. So that's what we want to do. What we've done before, we want to do it again and again and again. So that's just it. It's just as simple as that. You understand? Just shifting the major a and then trying to iterate through the remaining pair, the remaining array, the remaining item of the array, to check for a pair that will be equals to -a. So don't worry, we're gonna see more about it in the code implementation, but that's quite all you need to solve this problem. But let's handle this one now. Handling duplicate triplets. The question asks us not to return duplicate triplets. So how do we handle that? Alright, let's consider the this example here, so we can explain how we are going to handle duplicate triplets. So considering this example that is here now, we see that it is sorted. So one thing is that in solving this problem, we are going to be sorting the array first. So that's how to really optimize our solution to come across a more efficient algorithm. So we are going to be sorting it, and after that, now we know that we are looking for a triplet ABC such that a plus b plus c gives us 0, such that b plus c gives us -a. So let's consider the first element in the array, which is -4. Now considering -4, we know that we are really needing a b plus c that will give us -4. So because if a should be one of the pair, then a plus b plus c must give us 0, and b plus c must give us -a. So since a is -4, b plus c must give us 4. So you can even have it here that what we're looking for really is 4. You understand? So 4 is our target. We need a pair that will sum up to 4. So if you look at the array now, let's just glance through the array. You can see this element 1 and element 3 that will definitely give us, that will sum up to 4. So we can say that our b comma c is equals to 1 comma 3, such that now we found the pair, we found the triplets that is 1 comma 3 comma 4, sorry, comma -4. You understand? So you see that 1 comma 3 comma -4, if you sum it together, will give us 0, where -4 is a. You see, -4 is this a right here. We found a triplet. Alright, now moving our a to the next index. Don't forget, I said we are going to glance through every indices of the array so that you can find every possible triplet that we can have. So moving it to the next index now, we say I will still fall on -4, and if we look at it, b plus c, we need the pair that will give us that same 4. You understand? Because we are going after -a, and -a gives us 4. So we see that we still end up having another set of triplets, 1, 3, -4, due to the double occurrence of -4. So how do we go around it? Because we don't want to add this 1, 2, 3, 4 and still add this 1, 2, 3, 4 again. It's gonna result in a duplicate triplets, and the problem actually specify that we should avoid every duplicate triplet. So what do is that we are going to write our algorithm such that anytime that the current index or current element, this a, is equal to the previous element, is gonna skip it. Meaning that anytime we have come across a current element, you understand, and we have come across it before in the previous one, we're gonna skip it because it's definitely going to give us that same set of triplets. You understand? If it exists, you understand. So same thing apply here, where we have 0 here. 0 we might have a possible triplet that we for this particular 0. You understand? So, and if we should have it that way, then we are going to be having duplicate because there's another 0 right here again. So to avoid that, anytime we are iterating through the array, we are going to be making sure that the previous element is not the same as the current element. If it is the same, definitely we will be having the same set of triplets in the result, in our output. So, and why it works is that, don't forget, it is sorted. So if we are going to be having a duplicate number like 1 1 or 1 1 1 that will result in a duplicate triplet like that, they will always come side by side. You understand? They always come side by side. Why? Because it is sorted. So that's just the remedy to solve the problem for duplicates. Sort it first. After sorting, try to check if it is the same as the previous. If it is the same, then there's no need to check for it again, because if we could find any possible triplet, it will be the same set of triplet that we found for the previous element. So that's how you need to solve this problem. Let's summarize the whole logic that we use here. So it is that summary that we use to create the code and implement it in code in Python and JavaScript, and I'll be doing that in my YouTube channel, because this video is actually long enough, and you know, so many platforms won't allow me to upload this long video, so I have to do it on the rest on YouTube. So go to my YouTube channel, like, subscribe, and watch it. You are gonna enjoy it. So let's summarize the summary now. Let's summarize the logic now. We have an array is given to us. Array nums is the name of the array. So I want to find every possible triplet in the array, and what we are going to be doing is that we are going to be iterating through each element of the array. -4 first, -4 next, -2 next, 0 next, until we get to the end of the array. And for each iteration on each element of the array, we are going to be finding a pair that will sum up to -a. In this case, -4. So that will be 4, because my a is -4. So we are going to be finding a pair that will sum up to 4. You understand? And then after finding all possible pairs that will sum up to 4, we are going to shift our array again to the right by 1. So we are currently at -4 again, but because -4 is the same as the previous one, we are going to skip it, because it's going to give us the same set of triplets if possible. You understand? So we are going to skip it to the next one now, -2. And for -2, we are going to be calling the method. You understand? So we are going to be searching through the rest of the array to find any possible pair that will sum up to 2. Not -2 now, because we are dealing with -a, and in this case a is -2, so 2. So, and after doing that now, after finding a possible pair, we are going to come back again to 0. And what we do with 0 is that we are going to search through the rest of the array to find for any possible pair that will evaluate to 0. You know, -0 is still 0. So, and after doing that, we are going to move to 0 again, but because 0 already exists and 0 is there previously and you have navigated it, we are going to leave 0 to 1. So we are going to come to 1. I'm going to search through all the array for -1. So that's just what we are doing. And for each of these searching through the rest of the array that we are talking about, like now for -4, we are going to search through -4, and for -2, we are going to search through 2. And for each of these searching, we are just using what we discussed in the previous video. And what does it mean? We'll be placing a left and a right at the two extreme, and we are going to check if it sum to the target we are looking for. If it sum to it, definitely we found the pair. You understand? If it doesn't, we shift our left to the right or our right to the left, depending on how close it is to the target. If it is greater than the target, we know we have to shift our right to the left. If it is less than the target, we know we have to shift our left to the right. So that's just what we are going to be doing. So one extra thing please. We will be dealing with optimization. So you know, even though this code we are writing, or this code we just discussed, this logic we just discussed right now is optimized, it's gonna take a more efficient time complexity to run. You understand? But then there's a way we can optimize it even further. So an interesting optimization is that triplets sum to 0 cannot be formed using positive number alone. You understand? Actually, we are finding for triplets ABC. Let's deal with this now. A plus B plus C, that sums to 0, right? But A plus B plus C, if A is positive, you understand? Let me do it. Let me put a little bit of mathematics right here. So sorry. A comma B comma C. C is a member of positive integrals, positive real number. You understand? So it will never evaluate to 0. You understand? Let me remove the jargons now. You understand? So if A, B and C are positive integral, like 1, 2, 3, it can never sum to 0. At least one of them must be negative, so it can sum to 0. Because if the three are positive, even if it's just 0, 0, 0, it will still give us 0. But if we're having something like 1, 2, 3, 3, 2, 4, 5, 6, 7, 8, 9, you understand, they will always lead to a positive number. So in a situation whereby our A become positive, just like in this case, that our A become 1, definitely we don't need to continue the loop. Why? Because the array is sorted. So if our A can be 1, definitely everything that follow A will be 1 and above, because the array is sorted, and that means that everything will be positive, and that means we cannot find a triplet that will sum to 0 right from that position. Look at this position where our a is 1 now. If you want to go and check the remaining one, it will be 2 and 3, and there's no how 1 plus 2 plus 3 will make up a 0. So we should cut immediately there. You understand? At that point whereby it is greater than 0. Why? Because the array is sorted, and if a can be positive, b and c will be positive. So that's just the little optimization we'll be doing right there. So, and I bet I'm actually trying to tell you now that you see you are gonna enjoy the code implementation, because all this logic we just described now, we are going to be applying it there. Alright, let's dive into the code implementation. So we are gonna be solving the problem of triplet sum. So that's why I'm calling it triplet sum. Right now we are gonna be collecting the parameter, which is an array. So, and we will be returning a list of triplets. So, you know, I have the habit of writing down the parameters. So right here we have the parameter given. So the first thing we want to do is to sort our array. Don't forget we are dealing with sorted array, so we need to sort our array. Then we define the container that is going to hold our triplets. Let's call it triplets. And now after that we want to iterate through the norms. We want to iterate through the array norms. And why are we iterating? Don't forget that we, in the logic we explained, we iterate through the array norms, and for each of them, for each of the elements, we try to find the corresponding pair in the rest of the array. So that's what we are doing here now, iterating through it now and finding the pair that we sum up to that particular element from the rest of the array. So don't forget that in the process of optimizing the code, you know, the algorithm, anytime we encounter a positive element, we are going to be breaking from the for loop. Why? Because anytime we have a positive element now, every other element will be positive. Why? Because we sorted the elements. So if we should encounter a positive element at any point while iterating through the array, definitely every element that follows it is going to be positive, and that's not going to lead to a 0. So no matter what, it will always lead to a positive real number. So if norms of I, if it's greater than 0, definitely we could just break, because we could not, there's no way we are gonna find a triplet that will sum up to 0 if the smallest element in the triplet is greater than 0. You understand? So now let's try to check. Now if I is greater than 0 and norms of I is equals to norms of I minus 1, what we want to do at this point is that we want to continue. And what this actually means is that you know, in the situation whereby norms of I is equals to norms of I minus 1, there's definitely going to be repetition of triplets. So if in norms of I minus 1, say norms of I minus 1 is minus 4, if it has a duplicate and we found the duplicate and we have added it to our triplet right here, if we find another one again that still corresponds to minus 4, then definitely we are going to be adding the same set of duplicates to our list, to our triplets, and that's going to result in duplicate triplets. So we don't want to navigate any number that have been navigated before. So if norms of I equals to norms of I minus 1, we are not going to do it. We're just going to continue because we've treated it previously. So now what I want to do is that I want to collect our pairs. Let's call it pairs, and how we collect it is we are going to be defining a method. We can call it a function. So we will be passing our norms. We'll be passing I plus 1. Don't forget, it will be dealing with the remainder of the array. You understand? That's how we have I plus 1. So when we choose an element now, we go look into the remainder of the array, you understand, to try to check if we can find a pair that will sum up to that particular element. So that's why we are giving it I plus 1, and then we'll be giving him our targets. Our target is gonna be minus nums of I. Don't forget A. B plus C equals to minus A. So that's what that means there. So you see, everything is so logical. Once you understand the logic, you can write the code in any language at all. It's just like you are putting down English into writing. So, and what we do is that this particular function that we have here, pair sum, is gonna return every pair that sum up to the target that we're looking for, that's given by minus nums I. So, and what we do is that when we are gonna collect this pair and iterate through it for pair in pairs. And what we wanna do is that we add it to our triplets. Triplets dot append. We append into our triplets that pair. The pair will be a pair of B comma C, such that B plus C equals to the target equals to minus A. You understand? So, and why that's why we are putting a minus right here, so that it will convert it into a negative A. So, but if you follow with the logic, you will really understand what we're talking about here. So what I want to do now is that we are going to be adding A to it. So nums of I. You understand? So because what we have here, pair is just a pair B comma C. So we have to take that pair B comma C and add nums to it. So let's enclose nums inside a list. So it's gonna be like some sort of list concatenation or list addition. Hope you understand. So there's supposed to be an in here. Alright, so and at the end of the day, we just want to return our triplets. So we just want to return our triplets. So now let's define the function. Let's define the function pair sum, or the method pair sum now. So here we're gonna be collecting nums as usual, which is actually the list of integers, and we're gonna be collecting a starting desk. So this one means the starting desk. So it's gonna be an integer, and we're gonna be collecting a target, so which is also gonna be an integer. So and the return will be also a list of lists, don't forget. So because the question asks us to return every possible pair, so as much pair as possible we are gonna be returning. So writing our pair sum, what we want to do is simple. We have the start index and we have the target we are looking for. So right from the start index, we want to glance through the array from the start index. We want to glance through the array and placing our left to the extreme left, right to the extreme right, try to look and sum it up. It's gonna result in this target. If we do, then we add it to our pair that we are gonna return. You understand? Then we continue. Don't forget, we are not gonna stop there. We are gonna continue because we want to find every possible pair. So right, let's move on now. Okay, let's collect n to be the length of our array nums, length of our array nums, and let's define our left and right to be equals to 0, length of nums. So don't forget, that's the extreme we're talking about. So length of nums minus 1, and then while, don't forget that once left equals to right, then there's no way we are gonna find a pair any longer. So or once left becomes greater than right, there's no one to find a pair. So left has to be less than right if we are gonna find a pair. So while left is less than right, what we want to do is that we want to collect the sum, which is gonna be nums of left plus nums of right. And so we're gonna check if this total, if is equals to target. What we wanna do is that if total equals to target, then we found a pair. So what we wanna do is that, well, sorry, we're gonna be defining a pair right here. So I love doing things like this as well. So whereby I won't define variables until I need them. So I don't know, but I just like it that way. So we have these pairs. This way we are gonna be collecting every pair that sums to the target. You understand? So pairs that append So left comma right. So this list or list left comma right will be appended to the pair. So meaning that we found a target left, we found a pair left comma right that sums up to the target. But actually now we are not returning the index, we want to return the real values, you understand? So you see, when you see code like this, don't just think that, oh, they just do it, or no, there are actually principles, there are actually rules behind them. So we don't really need the index. What we need really is the number, is the element at those indexes, you understand? Because that's what the question asks, so that's what we are returning. So all right, in a situation whereby total is less than target, what do? In a situation whereby total is less than target, we actually we are gonna be increasing our left by 1. If you remember, we increase our left by 1. But in a situation whereby total is greater than target, what we do is that we reduce our right by 1. Now to avoid duplicates, because duplicates, just like we explained, will occur whenever there are two values that are the same, say -4 lying side by side. If -4 could give us a triplet, then definitely the next -4 that is beside it will give us that same set of triplets. So, and we don't want that. So while left is less than right, and we are going to be avoiding it now, and left, let's put it this way. So it's just code. Since we understand the logic, we just put it into code. So, and norms of left is equals to norms of left minus 1. So we keep on increasing our left plus 1. So what this place is just trying to tell us is that while norms of left, that is the element at index left, you understand why it is equals to element at index left minus 1, that is why it is equals to the immediate element before the current element. We want to increase our left by 1. So, and then we go back to check it again, that is it still the same. If it's the same, we increase it. We keep on increasing it as far as they are the same. Why? Because we want to avoid duplicate triplets. So that's what this actually means. And then eventually we're gonna return our pairs, so from the function. So that's just it. So don't forget, we return the pair and we collect that pair right here. So, and what we do is that we trade through that pairs. Now we try to add the third element in the triplet to it, which is the norms of I itself. So, and then we eventually return our triplet. So we eventually return our triplet. Now let's call the function now, print triplet sum of norms. Let's run it now. Oh, really? There are some amendments that we need to make in our code. So sorry about that. So, you know, don't forget, like we discussed in the logic, when we are dealing with the logic, we said when we take a particular element, then we try to iterate through the rest of the array, starting from that element through the rest of the array to find a pair that will sum up to that particular element. That's why we pass in this argument start into the pair sum method. So, but we are not using it right here, so it's not supposed to be 0 like it was here before. It's meant to be start, so that at any point in time it will start from I plus 1. Don't forget that it is I plus 1 that we sent into the pair sum here, so that it will iterate through the rest of the array. It's not iterating through all the whole array. So our left is not placed at the extreme, it's actually placed right beside the current element, so that it will iterate through the rest of the array, not the total array. You understand our logic that we applied the other time. So another thing is that before, this wasn't there, it was just like this, but we need to put into consideration that the problem statement asks us to return all possible occurrence of triplets that sums to 0. So we are not stopping whenever we have a total that is equals to targets. That is, whenever we have a pair that sums to targets, we are not stopping. Rather, we are going to continue by increasing our left by 1. So increasing our left by 1, we continue. So that's just it. So, and let's run it now. Alright, this is the JavaScript implementation of our logic. We've implemented it in Python, and now we want to implement it in JavaScript language. So we got our norms, and in this line we sort our norms. Don't forget, the first thing is that we get our array sorted. Then we create a triplet, which is a list that will help us to store the triplets that sum up to 0. So, and what we do is that we iterate through the array right here. We iterate through the array, and what we do is that for each of the iteration, don't forget that we're incrementing by 1. So starting from I equals to 0, what we want to do is we want to check if nums of I is greater than 0. So this is an optimization technique, because we know that when nums of I is greater than 0, then nums of I plus 1, I plus 2, I plus 3, all of them will be greater than 0. Why? Because we have sorted our norms. So, and if it's greater than 0, there's no way we want to find a triplet that will sum up to 0. So we break, and then what we do is that when we break, we return the possible triplet that have been stored previously. So, but in a situation whereby nums of I is not yet greater than 0, what we do is that we try to check again if I is greater than 0 and nums of I is equals to nums of I minus 1. We continue, meaning that we will not move on with the execution. We rather move on to the next element in the array. So, and keep on iterating. So now what we do is that we now collect our pairs. In a situation whereby these two conditions are not met, then definitely it will come here and call the pair sum function, passing in all the arguments that we have defined and listed. Norms represent the array, I plus 1 represent the start index. So whereby we are trying to look for a pair that sum up to the target minus norms, given the formula that a plus b plus c equals to 0 and b plus c equals to minus a. That's why we're having a minus right here. And after calling the function is going to return all possible pair that sum up to the targets, and we are going to iterate through this pair. And what we do is that we collect each of these pair, we will add these norms to it. Actually, in JavaScript, this is called destructuring. So because pair itself, this pair is a list of pair BC, and nums of I is just a number. So this dot actually is going to destructure this list of pair. So it's gonna destructure it. After destructuring it, it's now gonna combine them into a list. That's why we have this outer list here. So it's gonna convert them into a list and push them into our triplets, which is a list that is gonna store all possible triplets, and after that it's gonna return the triplet. So these are our function pair sum. Now the function define a pair, and it define the left and the right, and it places the condition that while left is less than right, we want to collect the total, and if total is target, we want to push the pair into it. So right now is a mistake here. We don't need to reduce the left. We just need to increase the right. We don't need to reduce the right. We just need to increase the left and keep on looking for any other pair that will sum up to the target. So there's no need for that actually. So, and after doing that, he tried to check also that while left is less than right and nums of left is equals to nums of left minus 1. So just keep increasing left while it is the same as the previous element, why the current element is the same as previous element, just keep reducing it. So we don't need this, so we don't need to keep reducing, right? You understand? Because if you can undo A and B, you understand, such that A and B does not contain duplicates, then definitely we don't need to undo C. You understand? So it's just fine, like we explained in the logic. So else, if total is less than target, we increase our left by 1, otherwise we increase our right by, I believe we understand this. So this one is trying to talk about, in the situation whereby fine, total is not equal to target, but total is less than target, we want to increase our left to the to go further to the right, so we can have a more tendency of reaching a positive and a more larger sum. So, and otherwise, if it is greater than the target, in this case we are going to reduce the right, so we can have a tendency of reducing the total sum, so we can have a high probability of reaching the target. So, and at the end of the day, we return the pair. So the pair will be collected right here and will be iterated through into the triplets, and eventually we return the triplet, and that's it. So you see, the same logic, different language. The next problem we're going to be solving next is going to be valid palindrome, and trust me, this valid palindrome is very commonly asked, across different top tier company. So don't miss it. Coming soon. Don't forget to subscribe, don't forget to follow. You understand? Sometimes you might not be online on LinkedIn and Facebook, and you might not get referred to YouTube. So YouTube has its own pop-up mechanism. So just on your data, you will see our post and you can watch it. So I wish you success, I wish you well. Thank you for listening.